In August 1945, a single bomb ended the largest war in human history. That bomb, and the entire secret project that built it, cost the United States around $2 billion. The airplane built to carry it cost $3. Not the fleet, the program. The delivery system was roughly 50% more expensive than the weapon it delivered, and almost no one who knows the name of the bomb knows the name of the machine that made it possible. The machine was the B-29 Superfortress, and the story that survives about it is a clean one. The plane that carried the bomb that won the war. A triumph of American engineering, arriving at the exact moment it was needed. It is a good story. It fits on a single line under a single photograph. It is also missing almost everything that matters. The legend keeps the weight in one place. A silver aircraft, a rising cloud, a war that ends a few days later. Compressed into that image is the quiet suggestion that the airplane was simply there, ready, the way a tool is ready in a drawer. As if the hard part was the bomb, and the airplane was just the hand that delivered it. But in January 1945, the most important B-29 campaign of the entire war quietly collapsed. The bases it depended on were abandoned. The bombers flew away and did not come back. The single most expensive weapons program in American history had just failed at the exact task it was built for, and the war it was meant to end still had 8 months left to run. To understand how that happened, and how a failure turned into the most famous success in the history of flight, it helps to stop looking at the airplane and start looking at the bill. Here is the flip. The B-29 Superfortress was not really an airplane. It was an economy. An ordinary weapon is a thing. A rifle, a tank, a bomb. It is manufactured, it is delivered, it is used, and the transaction ends. The Superfortress was not a thing. It was a standing demand. Every hour it existed, whether it flew or sat, it consumed something. Fuel by the ton. Engines that wore out faster than they could be built. Runways carved out of crushed coral by the labor of thousands. Spare parts flowing in rivers across an ocean. Crews who took the better part of a year to train and one bad night to lose. None of that appears in the legend, because none of it fits under the photograph. The airplane was only the visible tip of a supply chain that reached back across the Pacific, back to the assembly lines of Kansas and Georgia and Washington State, and down into the American treasury. Most histories measure the B-29 by what it dropped. This one measures it by what it cost to keep in the air. Because the real weapon was never the bomber alone. The real weapon was the machine behind the bomber. The vast, expensive, half-finished economic engine that had to exist before a single payload could reach a single target. Over the next half hour, the story moves in one direction. From the drawing board to the factory floor, to the freezing modification fields of Kansas, to the fuel dumps of China, to the burning engines over the Pacific. And it arrives at a single number that almost no one believes the first time they hear it. The plan to deliver the bomb cost more than the plan to build it. The airplane was the easy part to see. The bill was the part that decided the war. Start with the machine itself, because the machine was genuinely brilliant, and the story does not work unless that brilliance is understood first. By 1940, American engineers wanted a bomber that could do something no aircraft had ever done. Fly higher than the enemy could reach, farther than any ocean was wide, and carry a heavy load the entire way. Somewhere above 30,000 feet, across a range of several thousand miles, with tons of bombs in the belly. To get there, Boeing did not perfect one new invention. It stacked several unproven ones on top of each other in a single airframe at the same time. The first was pressurization. At 30,000 feet, the air is too thin to breathe and cold enough to freeze exposed skin in seconds. Every other heavy bomber of the war simply left its crew in that hell, packed into fur-lined suits, sucking oxygen through a mask for hours. The Superfortress sealed its men inside pressurized compartments where they could work in shirt sleeves, warm, breathing normally, while the world outside the aluminum skin sat at 40 degrees below zero. It was the first mass-produced bomber in the world to do it, but a sealed cabin created a new problem. A gunner cannot lean out of a pressurized hull to aim a machine gun into a 200-mile-an-hour wind. So the guns were pushed outside the pressure vessel entirely, into remote turrets, and the men who aimed them stayed inside, sighting through blisters of clear plexiglass. Their aim was routed through a set of General Electric analog computers, mechanical brains that corrected for the bomber's own speed, for gravity, for the range to the target. Even for the lead, a gunner needed to hit a moving fighter. One man could hand control of his guns across the aircraft to another. In 1943, this was closer to science fiction than to the open cockpit biplanes. Some of these crews had trained on barely a decade earlier. And under the wings sat the engines, 4 of them, each a Wright-R 3350, turning out 2,200 horsepower, more than almost any piston engine then flying, driving the whole machine up to an altitude where enemy fighters strained and flak lost its accuracy. The prototype first flew in the autumn of 1942, less than a year before the design was committed to full production. On paper, it was the most advanced aircraft in the world by a wide margin. Pressurized, computerized, and able to strike from beyond the enemy's reach. The scale of the leap is easy to lose. The heavy bombers already fighting the war reached out a few hundred miles and turned for home. The Superfortress was built to fly a mission longer than the width of the Atlantic and come back, carrying a bomb load heavier than anything before it, held up by a wing deliberately kept small and efficient to gain speed and range. That small wing bought performance, and it demanded a price in return. The airplane had to land fast and be flown with care, unforgiving of a tired crew or a failing engine. Even the shape of the thing was a bet. More reach, more load, more altitude, all wrung from a design running closer to its limits than anything that had flown before it. That was the vision. It was real, and it was dazzling. And almost none of it had been proven to work when the order came down to build it by the thousand anyway. Follow one airframe out of the factory, and the gap between the vision and the reality opens up fast. The order was staggering in its confidence. The government committed to the Superfortress and began pouring money into it before the prototype had finished testing, buying an unbuilt airplane off the strength of a promise. Production could not wait for a single plant, so the work was scattered across the country. Boeing built them at Renton and at Wichita. Bell built them in Marietta, Georgia. Martin built them in Omaha, Nebraska. Behind those 4 assembly lines stood thousands of subcontractors, each machining one piece of a machine most of them would never see whole. At first, it went badly. Building the Superfortress was so complex that early aircraft each swallowed more than 150,000 man-hours, and the design would not sit still. Engineers changed it constantly. So fast that airplanes rolled off the assembly line already out of date and had to be flown straight to separate modification centers to be torn open and rebuilt to the newest standard. That crisis came to a head in the winter of 1944. In a stretch of work the crews grimly nicknamed the Battle of Kansas. Brand new bombers, finished on paper, sat useless on the fields because the parts to complete them did not yet exist. Some had been waiting 2 months or more. With the first combat deployment looming, the effort turned desperate. Hundreds of specialist workers were pulled in from across the country, and they finished the airplanes by hand, outdoors, in the open, through a Kansas blizzard, working with numb fingers because there was no hangar large enough to hold them all. To even attempt this, whole new plants had to be raised from empty ground, some of the largest factory buildings in the country at the time, and staffed almost overnight with workers who had never built an aircraft in their lives, many of them women stepping onto a production line for the first time. The airplane was so far ahead of the tooling to build it that the factory and the design were, in effect, being invented together. And because the design kept changing, a whole second layer of the system existed only to fix what the first layer had just finished. Bombers flowed out of the plants and into modification centers that tore them apart and rebuilt them to the newest standard before they ever reached a squadron. The nation was not just building an airplane. It was building the machine to build the airplane and rebuilding it all at once. They got them flying. And slowly, the economy behind the airplane learned. The man-hours needed to build a single superfortress fell from more than 150,000 toward 20,000. That number is worth sitting with because it is not really a story about one airplane. It is the story of an entire industrial nation teaching itself in real time how to build something it did not yet fully understand. By the time the lines hit full stride, they produced nearly 4,000 of them. Each airframe, in 1944, carried a sticker price around $640,000. But that figure hides the real one. Spread the full cost of the whole program across every bomber built, and the true number climbs toward $900,000 per aircraft. In a war being fought with $60,000 fighters, the Superfortress lived in a category entirely its own, before it had dropped a single bomb. Now add the part that no price tag on the factory floor could capture. Buying the airplane was the cheap part. Operating it was where the real spending began. A Superfortress on a runway is not a finished purchase. It is an appetite. Before one could reach a target, it had to be fed fuel, measured in tons, loaded with bombs, fitted with spare engines that wore out at a frightening rate, and flown by a crew of 11 men, who each represented the better part of a year of training and a seat that had to be filled again the instant they were lost. And it needed somewhere to stand. Entire airfields had to be blasted and bulldozed out of small Pacific islands, their runways surfaced with crushed coral, built by construction battalions working around the clock, so the bombers would have 2 miles of level ground long enough to lift a full load into the air. On those islands, fields were carved out that would briefly rank among the busiest airports on Earth. Hundreds of superfortresses lined wingtip to wingtip, where months earlier there had been jungle. Each of those fields was, in itself, a major construction project. A small city of fuel tanks and bomb dumps and repair shops, existing for no reason but to service the appetite of the airplane. Every mission spent all of it at once. Nowhere was that appetite more brutal than in the first plan to use the bomber, a campaign to strike Japan from bases in China. On a map, it looked elegant. In practice, it was an economic trap. There was no way to supply those Chinese bases by land. Everything, every drop of fuel, every bomb, every spare cylinder had to be flown in over the Himalayas, over the route the crews called the Hump, one of the most dangerous flying corridors in the world. And the only aircraft with the range to haul that cargo was the Superfortress itself. So, the bomber was stripped of its guns and its purpose and turned into a flying tanker, hauling 7 tons of fuel over the mountains just to fill the tanks of the bombers waiting on the far side. The weapon spent most of its strength carrying the fuel it needed to become a weapon. At times, a third of all Superfortress flying hours were burned not over Japan, but on the supply run that merely made striking Japan possible. And behind every airplane stood its crew, another cost that never appeared on the airframe's price tag. 11 men filled a Superfortress. Pilots, a flight engineer managing the temperamental engines like a nurse over a patient, a navigator, a bombardier, radio and radar operators, and the gunners with their remote sights. Each had spent the better part of a year in training, a chain of schools and flight hours and practice missions running back across the whole country, and each was, in the coldest economic terms, a large investment strapped into an aluminum tube over hostile ocean. When an airplane went down, the nation did not just lose a machine worth the better part of $1 million. It lost 11 of those investments in a single stroke and had to begin replacing them the next morning. The arithmetic was merciless. To gather enough fuel and bombs for a single raid took so many supply flights that the entire force could manage, at best, 1 combat mission a week. A weapons program measured in billions, delivering 1 strike every 7 days. The machine was not being defeated by the enemy. It was being slowly bled by the sheer cost of standing where it stood. And then there was the crack running through the center of the whole thing. The engines. The warning came before the war even reached the airplane. In February 1943, long before mass production, the second prototype lifted off from a field in Seattle with the company's most experienced test pilot at the controls. Minutes into the flight, an engine caught fire. Then, a second. The pilot fought to bring the crippled machine back, missed the downtown by a margin, and came down into a meatpacking plant south of the city, where nearly 5,000 gallons of fuel turned the crash into an inferno. Everyone aboard was killed. So were roughly 20 workers inside the building, and a firefighter who answered the call. The most advanced bomber in the world had killed nearly 30 people before it ever carried a bomb, and it had done it with its own engines. That was not an isolated flaw. It was the airplane's signature. The Wright R-3350 was the heart of the Superfortress and the most dangerous part of it, not because of anything the enemy did, but because of what it did to itself. The engine ran hot. The rear cylinders sat starved of cooling air, and under the strain of dragging a fully loaded bomber up to altitude, they could overheat and ignite. An engine fire is dangerous on any aircraft. On the Superfortress, it could be a death sentence because of a decision made to save weight. Parts of the engine were cast from a magnesium alloy, and magnesium does not simply burn. It burns at temperatures approaching 5,600 degrees, hot enough that a fire could burn through the main spar, the central bone holding the wing to the aircraft, in seconds. When that happened, the wing folded, and the airplane and its crew were gone before anyone could reach an escape hatch. Men died in these fires who never saw an enemy fighter. They died on takeoff, heavy with fuel, when an engine lit and the spar gave way before the wheels were fully up. There was a bitter joke among the crews that they were being killed less by the enemy than by the company that built their engines. It was the kind of joke men make when the truth is too heavy to say plainly. The engineers fought it for years, reworking the cooling, moving to fuel injection, stretching engine life from 100 hours between overhauls to 400. The fixes worked, gradually. They never fully erased the flaw. And here is the turn the whole story has been building toward. That flaw was not a defect bolted onto a good design. It was the good design. The strength and the fatal weakness were the same thing, seen from two sides. Look again at what made the Superfortress revolutionary. It flew higher than anyone else, which meant its engines had to strain harder than anyone else's. It carried farther than anyone else, which meant it flew heavier, which meant more heat, more stress, more fire. Every quality that made it a war-winning machine was also the exact quality that made it fragile, ruinously expensive, and lethal to the people inside it. The ambition and the danger were not two features. They were one feature, wearing two faces. Every takeoff carried this shadow. A Superfortress, leaving the runway at full weight, fuel, and bombs aboard, was a machine asking its worst component to work hardest at the worst possible moment. Crews learned to watch the engine temperatures climb during the long, straining climb to altitude, and to wonder, quietly, which of the four might be the one to go. Aborted missions, aircraft turning back before reaching the target because an engine ran too hot to trust, were not rare events. They were a running tax on the whole enterprise, another airplane's worth of fuel and effort spent for nothing, over and over. Then came the cruelest twist of all. The single most expensive capability in the entire design, the ability to bomb from above 30,000 feet, turned out to be almost useless. High over Japan, the bombers ran into a river of wind no one had planned for, a jet stream that could tear across the sky at more than 100 miles an hour. This was not a known hazard the crews had failed to account for. It was, in effect, a piece of atmospheric science the world was discovering in real time, at bombing altitude the hard way. Bombs released into that current were flung far from their targets, drifting for miles as they fell. The precision the whole airplane had been built to deliver simply blew away on the wind. The most advanced high-altitude bomber ever made could not reliably hit what it aimed at from the altitude it had been designed, at staggering cost, to reach. So, the commander in the Pacific did something close to heresy. He threw the expensive advantage away. He stripped much of the defensive armament out of the bombers, loaded them with incendiaries, and sent them in low, at night, at 5,000 feet, the very thing the pressurized, high-flying design had been created to avoid. It worked, with terrible efficiency. In a single raid on Tokyo in March 1945, a few hundred superfortresses burned out some 16 square miles of the city and killed on the order of 100,000 people in one night. The airplane finally became devastatingly effective only by abandoning the capability that had made it so expensive in the first place. This is the law the Superfortress teaches, and it is worth naming plainly. Call it the law of the delivery cost. Every decisive weapon hides a second weapon inside it, the machine built to carry it to the target. And that second machine is almost always the larger, the costlier, and the more fragile of the two. The proof is in the wreckage. Across the war against Japan, 414 superfortresses were lost. Only 147 fell to the enemy. The other 267 were lost to fire, to failure, to crashes. For every airplane the enemy destroyed, the machine destroyed nearly 2 of its own. Return now to that collapse campaign, the one from the very beginning, because now the reason it collapsed is visible. The plan to bomb Japan from China had a name, and by early 1945, that name stood for failure. The bases sat deep in China, and the bombers first struck out from them in the summer of 1944 against a steelworks on the Japanese home islands. It was a historic raid, the first time the home islands had been bombed since the war's opening months. It was also, as economics, a disaster. Over months of operations from China, the force flew only a small string of missions against Japan, each one preceded by weeks of fuel hauling over the hump just to make it possible. The bases could never be supplied cheaply enough to justify what they produced. The Superfortress spent its strength carrying its own fuel over the mountains, managed only a handful of raids, and inflicted damage that came nowhere near the staggering cost of putting it there. The most advanced bomber ever built was being used, in effect, to deliver a message that it existed, at a price that could have funded a small navy. So the campaign was abandoned. The bases in China were given up, and the whole force was pulled out and relocated thousands of miles to a chain of small islands in the Pacific, seized at great cost for exactly this purpose. It was the correct decision. It was also an admission that the first, most expensive attempt to use the most expensive weapon of the war had not worked. The collapse date was real. The failure was real. What changed everything was not a better airplane. It was a better address. From the islands, the fuel and bombs arrived by ship straight to the coast, instead of over a mountain range, one plane load at a time. The crippling supply arithmetic finally eased. The same bombers that had managed one mission a week from China now launched in the hundreds. The Tokyo firestorm was flown from those islands, more than 300 bombers in a single night, a scale that would have been physically impossible from the Chinese bases just months before. The machine had not been fixed. Its economy had. The gamble only began to pay off once the supply line stopped devouring the weapon it was meant to support. Which raises the obvious question. If the program was this expensive, this dangerous, this close to failing outright, why did no one stop it? The answer is that by the time the trouble was fully visible, stopping was no longer possible. For 2 reasons that fed into each other. The first was ordinary. Billions had already been committed, spread across factories and cities and hundreds of thousands of jobs in a dozen states. A program of that size builds its own momentum. It becomes too large, too woven into the national economy, too politically heavy to cancel, almost regardless of how it is performing. The spending itself becomes a reason to keep spending. Every plant retooled, every worker hired, every subcontract signed added another weight against ever turning back. The second reason was the one that mattered most, though almost no one involved could have known it. In complete secrecy, another program was building a new kind of weapon, and that weapon would need a way to reach Japan. It would be too heavy, too large, and too precious for any other aircraft in the American arsenal. Only the Superfortress could carry it. A small number of them were quietly pulled aside and rebuilt in secret, stripped and modified to cradle a single enormous bomb, flown by a special unit kept apart from everyone else and told almost nothing about what they would drop. The secrecy was total. The unit trained apart, on a distant island, flying practice runs that dropped a single strange, heavy shape and then turned hard away. And even the men doing it were told almost nothing about why. Their airplanes were subtly different from the thousands of others, lightened and rebuilt around a cargo none of them could name. To the rest of the vast enterprise, they were just a few more superfortresses among 4,000. So the program could not be stopped, because the thing it was truly for had not yet been revealed. The nation was pouring $3 billion into an airplane to deliver a weapon most of the people building the airplane did not even know existed. The gamble had to keep running, because folding the hand would have meant having no way to play the card that had not yet been dealt. So return, one last time, to the number that started all of this. The secret project to build the atomic bomb cost the United States somewhere around $2 billion. The program to build the airplane that carried it cost roughly $3, and by some accounts closer to $3.5. The exact figures are argued over to this day, and honesty requires admitting the accounting is not clean. Different sources draw the boundaries of each program in different places. But even at the most cautious reading, the direction is not in doubt. The delivery system cost more than the weapon, and measured in today's money, the gap does not shrink, it widens. Carried forward to the present, the bomb program lands somewhere around $35 billion, an enormous sum. The airplane program lands well north of $80 billion, more than twice as large. Whatever the exact accounting, the shape of it is fixed. Across 8 decades and every adjustment for inflation, the machine that carried the bomb stays stubbornly, decisively more expensive than the bomb itself. That is the law of the delivery cost, written as large as it has ever been written. The bomb is remembered as the thing that ended the war, and in a sense it was. But a weapon that cannot reach its target is not a weapon, it is a rumor. Before the bomb could change history, someone had to build a machine capable of lifting it, carrying it thousands of miles, and holding it steady over a single city. And that machine turned out to be larger, costlier, more dangerous, and far more troubled than the bomb it was built to deliver. There is a temptation to hear all of this as an argument that the Superfortress was a mistake. It is not. The airplane worked, in the end, and the thing it delivered did end the war. The point is smaller and stranger than a verdict of failure. It is that the part everyone remembers, the bomb, sat at the tip of something vast and mostly invisible, and that the invisible part was the larger achievement and the larger gamble. A nation bet more on the carrier than on the cargo, spent more, lost more men to it, and then folded the whole enormous effort down into a single sentence that leaves the machine out entirely. The world kept the simple story. The plane that dropped the bomb that won the war. But the simple story puts the weight in the wrong place. The bomb was the ending. The Superfortress, and the vast, straining, half-broken economy behind it, was the machine that made the ending possible. America did not merely build a bomb to end the war. First, quietly, and at a cost almost no one remembers, it had to build something big enough to carry it there. The bomb was the headline. The airplane, and the whole straining economy that kept it flying, was the price of admission that made the headline possible at all. The payload gets the monument, the machine that carries it gets the bill.